Here we're going to talk about cost behavior, and this is chapter 3 in your particular book that we're currently using. Cost behavior refers to how costs behave, how they behave if some activity changes. If we build more dog houses, how does the cost for lumber change? Well, if I build more dog houses, I'm going to need more lumber. So the total cost of the lumber that I'm going to have to pay for is going to increase because I increased the number of dog houses. Okay? So that is what we're looking at. How does a certain cost behave if we have changes in the activity, in the volume? Okay? And these are activity drivers, such as the volume of dog houses that we're going to build. Okay? We also need to know about the words called relevant range. That means I'm going to look at what I normally expect is the most number of dog houses that I'm going to build. So if in the size of the factory building I have, the largest number of dog houses that I can build is 1,000 dog houses in a month, then in that case, I'm not going to worry about the fact that the cost might behave differently if I were to make 2,000 dog houses, because that's outside of the relevant range. So you have to know what the relevant range is, and we're going to restrict how the costs behave to what happens within that relevant range. If we go outside the relevant range, then we have to refigure out how the costs might behave. Now, costs are divided into 3 different types, and the first type is called variable costs. That means those are the kinds of costs that vary in proportion to the changes in level of activity. So, in other words, if we build more dog houses, we will need to spend more on lumber. If we build less dog houses, we will need to spend less on lumber. So the cost of the lumber is going to go up and down depending on how many dog houses, which is the activity, how many dog houses we're building or not building. Okay, so the lumber, which is a direct material, would be a variable cost. Here's another example. Jason produces stereo sound systems. The parts are $10 per unit that they need to buy from some outside supplier to put into the stereo systems. Then Jason assembles the stereos in their Waterloo plant. Okay, so these parts that are $10 per unit are a variable cost, because here it shows us what if we build 0 stereos, then it will cost us 0 for those parts. If we, this is in thousands, if we make 30,000 stereos times $10 a piece for each part, our total amount we're going to have to pay for that part is $300,000. Okay, so as we build more stereos, that's the x-axis is the number of units, and the y-axis is dollars. Okay, in this case, it's the direct materials cost, the total direct materials cost. Okay, so as the number of units go up, the total cost for our direct materials also goes up. And we can plot that on a graph and draw a line and have a line. And a variable cost graph usually is going to look like this. It's going to have a diagonal line going from the bottom left up to the top right. Now this graph shows you a unit variable cost graph. In other words, how much does it cost us for one set of parts? Well, again, the number of units are on the x-axis and the dollars are on the y-axis. So it costs us $10 for each set of parts. And no matter how many we make, it's going to still cost us $10 per part. So the total amount we have to spend for parts goes up the more number, but the cost for one set of parts stays the same. Okay, so here shows you a table, okay, 5,000 units, 10,000, all the way up to the 30,000 units. So our relevant range is, up to 30,000 units. Okay, and then it costs us $10 a piece for each set of parts, and the number of units times the $10 is the total amount we have to pay for those parts. Okay, so all the way down. Then we can plot those. So the total line is going to look like that, whereas the cost per set of parts stays flat at $10. So a variable cost always acts like this. A variable cost always has this diagonal line on the graph. The total costs are going to go up if the number of units goes up. Whereas the cost for one unit stays the same. No matter how many we produce, as long as it's in the relevant range, the cost for one stays flat. All right, the second kind of costs that we need to talk about are fixed costs. And fixed costs are costs that remain the same in total as the level of activity changes. So something like rent. If we pay rent for the factory building, then it doesn't matter how many doghouse, how many stereos we build, we still have to pay the same rent. So rent would be a fixed cost. So here's another example. Here's the production supervisor for the Los Angeles plant is Jane Sovisi. And she is paid $75,000 a year. And the plant produces from 50,000 to 300,000 bottles of perfume. Okay? So no matter how many bottles of perfume they're making, she is just getting her flat salary of $75,000 a year. So that is a fixed cost. So here's again all the different amounts of bottles we might make, all the way up to 300,000. That's our relevant range. But her salary stays the same. Now, if we want to figure out how much of her salary, because that would be an indirect, right? She's a supervisor, so that would be indirect labor. Okay? So it's not like her salary is being divided into all the bottles, as part of the cost of the bottles. But as indirect labor goes into overhead as part of the overhead cost. But still, if we wanted to just see how much of her salary is per bottle, if we were making 50,000 bottles of perfume, we'd have $75,000 divided by the 50,000 bottles. That means every bottle is a cost of $1.50 of every bottle is helping to pay Jane's salary. Now, if we make 300,000 bottles, we have $75,000 divided by 300,000 bottles, it's only 25 cents. Each bottle is carrying 25 cents of Jane's salary that we have to cover. So the more bottles we make, each bottle carries less of Jane's salary. So here shows you the two graphs for fixed costs, and this is typical for all fixed costs. The total cost of the rent or her salary, etc., the total cost would be a flat line across. Okay, at 75,000. Doesn't matter how many bottles we make within the relevant range, that's the salary. Whereas if we were to divide it per bottle, then the lower number of bottles we make, the more of her salary has to be covered in that bottle. And it goes down as the more bottles we make, then each bottle only has to cover so much of her salary. Okay, and so this is typical of fixed cost. The total is flat, but the per unit goes down the more we make. All right, the third kind of cost is a mixed cost, and it can be partially variable and partially fixed. Okay, and so we have to figure out how much is variable and how much is fixed, usually. Sometimes mixed costs are costs semi-variable because they're part variable, or semi-fixed because they're also part fixed. Okay, so that's just extra terminology that might be used out there in real life. Here's an example. Simpson manufactures sales using rented equipment. The rental charge for the equipment is $15,000 a year. They have to pay for that piece of equipment. And if they use more than 10,000 hours during the year, they have to pay $1 for every hour that's used above the 10,000 hours. So the first 10,000 hours they use the machine, they're going to pay $15,000 that year for that machine. Okay, so here shows a graph. So the first, across the x-axis is the total machine hours in thousands. So the first 10,000 machine hours are $15,000. That's a fixed part because it's just flat across there. After that, every hour that we use the machine above 10,000, so if we use the machine 40,000 hours, we're going to pay $15,000 plus we will pay an extra $1 for the other 20,000 whatever hours. Okay, and so this is how much we're going to have to pay for that 40,000 hours. That part that goes from 10,000 on up is the variable part of the line. Typically, management needs to make decisions that involve how much of something is variable and how much is fixed. So we need to separate those out. And one method to do that is the high-low method, and there are other methods. In the next PowerPoint, we'll discuss how to separate out variable and fixed costs